Good morning, and once again, I'm coming to you from the Comfort Inn at JFK International Airport. My name is Dolphy Gilpin, Dolphy Alexander Gilpin in full, and I'm in the continued session of demonstrating the multiple dimensional application of my amazing 5x12 matrix. And for this session, what we'll do, we'll use the 5x11, 5x12 matrix, and instead of generating the zeros like signs in infinite series or dollar zeros like sign infinite series, we will do the full processing down to the 2x2 paired matrix, and then use the paired 2x2 matrix as input parameters to circuit analysis problem, electrical electronic circuit analysis problem. And we'll integrate now the Norton equivalent and Thevenin equivalent, and we'll have some voltage and some current 2x2 paired matrix solutions. But before we could get to that, let's start off by projecting our 5x12 matrix. My name is Dolphy A. Gilpin. And let's project the same 5x12 matrix. Yeah. So let's see. Okay, it's now HF 0583 10 6 0583 10 0583 3106 0583 0583 3106 AE 71939 AE 71939 428B. This is a B. LG 900 699 65C, and LK 95 31 75 95 35 175 19 C, and the last one was now an LL 06811 535 star. And this was actually the configuration of this 1x11 from the source I took it from. So this star is just like an alphabet. I will treat it as such. All right, but let's use the starred one in our example. And do you know methodology now? We use the LL star operator. And for the LL star operator, LL star, what we had was during the breakdown analysis, 0583 3106 LL be 0583 3106 719399 719399 28. With a 4 supposed to make like a 9, 3, 9, 4, 3, 9. So this is a 4. And 900, 599. 900, 599. 65. I'm going too fast, so let's slow down. 900, 599, 599, 65, and 953, 175, 953, 175, 90. And we're not here trying to demonstrate the methodology because we're going to be using the outputs or the result to solve our circuit analysis problem. So this would be the next step. And so furthermore, we'll have now LL star say 05 into 93, 94, 28, 05, 99, 65, and 31, 75, 19. We're just using one, the LL operator, or the LL star operator. And during the methodology, the processing, we'll have LL star 05, and the next one will be LL star 71, LL star 71, we have, 83, 31, 06, 05, 99, 65, and 31, 75, 90. Next one will be LL star 90. For that, we'll have 83, 31, 06, 93, 94, 28, and 31, 75, 19. Next one we'll have LL star 95. And for that we'll have now 83, 31, 06, 93, 94, 28, and 05, 99, 65. And so on and so forth. And what we generate 16 of these type here, because we'll have now LL star 17, LL star 50, LL star 31, LL star 05, LL star 93, 83, all producing this 1, 2, 3, 3 by 6. All right, we're going to mix up some of these steps, and we use just the first column here, and the first period in the first column. And remember, no objective is not to generate the infinite series of 1 by 11, 1 by 12 matrix or serials. But our aim here is to use the 2 by 2 as input parameters in solving circuit analysis problem by the metrical mesh analysis method. All right, so we are the LL star. LS star 05, LS star 71, LS star 90, LS star 95. Okay, let's use LS star 71. And the next step in our LS star 71 will take now, we're just using this one. We could have used this one, this one, this one, this one. Let's take this one and we say the next step would be LL star 71, 83 into 99, 65, 75, 19. Next one will be LL star 71, 05, 83, 05, then 31, 05, the 31, 06, 75, 19. The next one will be LS star 71, 31, using this particular breakdown, 31, LS star 71, 31 into 31, 06, and 99, 65. And the next one will be LS star 71, 75. We could have used 31, but I don't like to jump from 31 to this one here, or from this one to this one. I used to come down, go so, come up, and come down. So the next one will be 75 operator. And for that, we'll have the matrix 83, 06, 05, 65. Now these 2 by 2 paired matrix will be used as input parameters in circuit analysis, mesh analysis problem. All right, so what we'll end up with is that we're going to be taking, say, the determinant of this LL star 7183 operator, which is corresponding 2 by 2 paired matrix will be 96, 65, 75, 19. And so we'll take now the determinant of 96, 65, 19. And for that determinant, that will equal to now 96 multiplied by 19 minus 65 multiplied by 75. Should be L star 782 should be 83 with 99, 65, 75, 19. 99 it should be. 99. So this should be 99. All right. So the determinant of this, and this is not a course for arithmetic, so if somebody with a calculator could just get the answer for this. And I believe the answer would be minus 3054. You could check with your calculator. I did this arithmetically and we're subjected to arithmetic mistake. So I think it's minus, it came out to a minus 3054. And say this was a circuit analysis in which the answer would have been in amps or volts, or say amps. So this would be minus 3054, say amps. And we interpret this now as being the opposite to the assumed direction of the current in the mesh or the circuit the circuit setup. So that if you had the current set up as going so, that is the ammeter and the circuit going so, then and we get a minus answer, then actual direction of the current would be as so. All right, let's do another 2 by 2. We're doing some exercise in this 2 by 2, and then we'll actually set up our matrix and our circuits with the parameters, the resistance and voltages and currents. So we have LS star 7105. LS star, and we take the determinant of the corresponding operator, LS star 7105, which would be the determinant of 3106 and 7590. And that determinant, this is, as I said, another course for arithmetic here, so we're going to just write down the answer. That would be, 31 multiplied by 19, 31 multiplied by 19 minus 75 multiplied by 6. And clearly, let's see which one is bigger here. Did we get a negative answer again? And that's equal to 99. We'll check this by a calculator. This was a Thevenin problem, this would be in volts, or not in current. So let's say this was 99, and could be 99 volts or 99 amperes or what. But for this one, let's take the 2 by 2 for this operator LS star 7131. The corresponding 2 by 2 would be 3106 9665. So we have the determinant of 3106 9665. And so that will be equal to 31 multiplied by 65 minus 99 multiplied by 6. And that's equal to 1421 units. Could be amperes units, could be volts units. Okay. And for one more, let's do this one, which is LS star 7175. Also, we take the determinant of the corresponding matrix here, 2 by 2 paired matrix, and 8306 and 0565. And the determinant of that period 2 by 2 would be 83 multiplied by 65 minus not multiply, but rather minus 5 times 6. 5 multiplied by 6. And that's equal now to 883 units of voltage or amperes, depending on the circuit mesh setup. And we could go on and on. We're going to be getting a lot of these. I think 16 2 by 2s from this LS star. We've only done 4 of them. And like I said, our aim here is to use these 2x2 setup in circuit analysis problems solved by the mesh analysis. We're going to be using the same V equals IR, Kirchhoff current law, and Kirchhoff voltage law. And the mesh analysis is one particular method to solve these circuit problems. And we'll get some 2x2s. In other cases, we'll get some 3x4, some 4x4 matrix, and we'll have to solve them to get our answer. Well, the time allotted to me has expired here, and so we'll try to get some longer session in, but the next time we'll actually set up our circuits and solve these problems, these circuit analysis problems, via the matrix mesh analysis. So this is Dolphy Gilpin signing out from the comforting JFK International Airport. Thank you so much.